Section 590.6b of the National Electrical Code, specifically the 2005 Handbook, addresses the use of receptacle outlets for portable tools and appliances in temporary wiring situations. It states that where portable tools or appliances are used at more than one location, and the cord exceeds the length specified in 590.6a, or where the cord may be exposed to damage, the receptacle outlet shall be located in a box or cabinet. The core intention of Section 590.6b is to protect personnel from electrical hazards, primarily electrical shock and electrocution. This protection is achieved by ensuring that receptacle outlets are properly enclosed and protected from physical damage, reducing the risk of accidental contact with live electrical parts. Now the question arises, does Section 590.6b implicitly or explicitly include 480 volts connections? The text of this section does not specifically exclude 480 volts connections. This lack of explicit exclusion leads to interpretations regarding the applicability of GFCI, ground fault circuit interrupters, to 480 volt systems in temporary power setups. GFCI devices are designed to protect individuals from electrical shock by monitoring the current balance between the hot and neutral conductors. If a difference in current, indicating a leakage to ground, exceeds a certain threshold, typically 5 milliamps, the GFCI quickly interrupts the circuit, preventing a potentially fatal shock. Now let's consider the requirements set forth by OSHA, the Occupational Safety and Health Administration. OSHA mandates the use of GFCIs for temporary power installations at construction sites. However, this requirement typically does not extend to 480 volts connections. The rationale behind this exception is that the risk profile associated with higher voltage systems differs from that of lower voltage systems, such as 120 volts or 208 volts. At higher voltages, the current flow through the body is more likely to cause severe burns and cardiac arrest, rather than the ventricular fibrillation associated with lower voltage shocks. Consequently, alternative protective measures, such as adherence to strict safety protocols, use of personal protective equipment, PPE, and implementation of comprehensive grounding systems, are often considered more effective for high-voltage systems. The absence of a specific requirement for GFCIs on 480 volts connections by OSHA does not imply that such protection is unnecessary or undesirable. Rather, it reflects a recognition that other safety measures can provide adequate protection, and that the implementation of GFCI protection on high-voltage systems may present technical challenges and potential operational issues. For instance, nuisance tripping of GFCIs due to normal leakage currents in large industrial equipment can disrupt operations and create safety hazards of their own. The National Electrical Code, NEC, does not explicitly prohibit the use of GFCIs on 480 volts connections. This ambiguity leaves the decision of whether or not to implement GFCI protection on 480 volt systems to the discretion of the electrician, the contractor, or the responsible electrical engineer. When making this determination, it is crucial to consider several factors. Firstly, a thorough risk assessment should be conducted to identify potential electrical hazards and evaluate the likelihood and severity of potential injuries. Secondly, the specific characteristics of the electrical system and the equipment being used should be taken into account. Factors such as the type of grounding system, the presence of sensitive electronic equipment, and the potential for leakage currents can influence the effectiveness and reliability of GFCI protection. Thirdly, applicable industry standards and best practices should be consulted to ensure that the chosen protective measures align with accepted safety principles. In some cases, it may be deemed appropriate to implement GFCI protection on 480 volts connections, particularly in situations where there is a high risk of electrical shock or electrocution. For example, in wet or damp locations, or where workers are in close proximity to energized equipment, GFCI protection can provide an additional layer of safety. However, it is essential to carefully select and install GFCI devices that are specifically designed for use on high-voltage systems, and to ensure that they are properly tested and maintained to ensure their reliable operation. The decision of whether or not to use GFCIs on 480 volts connections is not a one-size-fits-all solution. It requires careful consideration of the specific circumstances and a thorough understanding of the relevant safety principles and technical considerations. In addition to GFCI protection, several other safety measures can be implemented to reduce the risk of electrical hazards in temporary power installations. These include, firstly, proper grounding. Ensure that all equipment and metal enclosures are properly grounded in accordance with the NEC requirements. Grounding provides a low impedance path for fault currents, helping to trip over current protective devices and reduce the risk of electrical shock. Secondly, insulation. Regularly inspect cords and cables for damage and replace them if necessary. Ensure that all electrical connections are properly insulated to prevent accidental contact with live parts. Thirdly, overcurrent protection. Use circuit breakers or fuses to protect circuits from overload and short circuits. Select overcurrent protective devices with appropriate interrupting ratings to safely clear fault currents. Fourthly, lockout/tagout procedures. Implement lockout/tagout procedures to energize equipment before performing maintenance or repairs. This prevents accidental energization of equipment while work is being performed. Fifthly, training. Provide workers with comprehensive training on electrical safety practices. Ensure that they understand the hazards associated with electricity and how to work safely around energized equipment. Sixthly, personal protective equipment. Require workers to wear appropriate personal protective equipment, such as rubber gloves, safety glasses, and insulated boots when working with electricity. PPE provides an additional layer of protection against electrical shock and burns. Seventhly, regular inspections. Conduct regular inspections of temporary power installations to identify and correct any safety hazards. This includes checking for damaged cords, loose connections, and improper grounding. Eighthly, ground fault protection other than GFCIs. Ground fault protection of equipment, GFP, can be used to detect ground faults and energize the circuit. GFP is typically used on larger electrical systems and can provide a higher level of protection than GFCIs. Ninthly, isolation. Isolate energized equipment from workers by using barriers or enclosures. This prevents accidental contact with live parts and reduces the risk of electrical shock. Tenthly, awareness. Promote a culture of safety awareness among workers. Encourage them to report any potential hazards and to take proactive steps to prevent accidents. It is important to recognize that the NEC and OSHA requirements are not static. They are subject to change over time as new technologies emerge and as our understanding of electrical hazards evolves. Therefore, it is essential to stay informed about the latest revisions to these codes and standards and to ensure that electrical safety practices are aligned with the most up-to-date requirements. Consulting the latest editions of the NEC and OSHA regulations, as well as relevant industry standards, is always recommended to ensure compliance and to maintain a safe working environment. In conclusion, while the NEC does not explicitly prohibit the use of GFCIs on 480 volts connections, OSHA does not mandate their use. The decision to implement GFCI protection on 480 volt systems is a complex one that requires careful consideration of the specific circumstances, a thorough risk assessment, and a comprehensive understanding of the relevant safety principles and technical considerations. By implementing a combination of GFCI protection and other safety measures, it is possible to reduce the risk of electrical hazards and to create a safe working environment for all personnel.